All right, and this is going to be part 5. All right, and then again, here are these concepts we've gone over. We understand inference, hopefully. We know how to calculate a point estimate for a population proportion. We can construct a confidence interval estimate. We've done that with data. Now we're going to do it with statistics. So what if I'm given p hat instead of the x and the n that I need to put in the calculator? And then we'll interpret the confidence interval as well as I answer a few questions and really understand what those numbers mean. All right, so in this example, we're told that a Consumer Reports Research Center survey of 427 women showed that 29.0% of them purchased books online. So this is different from the example we did in part 3, because now we have a percentage rather than just a set number. So in the example we did earlier, we had the x and the n that we needed in order to get p hat. Now we have p hat and n, and we have to be able to get x. And so we need to be able to use these numbers, but it's actually kind of nice because we can still use our formula, p hat equals x over n, but how do I get x by itself? I know p hat and I know n, so if I use this down here, I could say, of course I want to change this to a decimal, so 0.290 equals x over 427. And so what would I normally do to figure out what x is? Hopefully you are telling me, if not out loud, would be kind of nice, but I get it. At least in your head, you're saying, I would multiply both sides by 427. That's going to get me x by itself. And that makes sense because 29% of the total is the number of women who've said that they purchase books online. When I do this, I get 123.83. Now, what's wrong with that value? Hopefully, you're looking at your screen funny and wondering, how can that be? Well, what's happened is they've had to round their percentage at some point. And what they've probably done is they had 124 women who said that out of the 427 who said that they purchased books online. But when we calculate that, when we take 124 divided by 427, we get 0.2903. So let me see if I can slide. Oh, no, I can't do that. I'll change colors. There we go. So if I take 124 out of 427, I get 0.290398, and it keeps going. And so what they've done is they've just rounded this to the nearest tenth of a percentage. If we had rounded down, so I'll come over here, just because I don't have a lot of room, I'll come over to the right-hand side. If we had rounded down and said 123 out of 427, that would have given us a slightly wrong number. And the decimal, this right here, 0.0%, really helps us know that we did need to round up, because this is going to give me 0.28805. And I can't get the 5 to, I've got something in the way that's part of my controls for my whiteboard, but there we go. Just assume that there's a ... there. And so this would not round. to 29.0%. It would round to 29%. And so, it seems like a very, very fine line there. And I will say this, a lot of times the homework will actually take your answer of rounding up or rounding down. So don't be too worried about it. But in this case, we want to round appropriately. There is a time when we're looking for sample size, and we'll talk about that just a little bit separately. But there is a time when we will want to round up no matter what. So even the, if traditional rounding says round down, we would still round up. And we'll talk about why and when we will do that. But for now, for this situation, we just want to round appropriately. So we would say 124 women who were surveyed said that they purchased books online. All right, so remember that we said there were two conditions we had to check in order to be able to use the one prop z int. And those two conditions were to check that n times p hat times 1 minus p hat was greater than or equal to 10. And so in this case, I actually have, remember, we have p hat is 0.290, and we have n. So those are the two values I want to use. So I'm going to say is 427 times 0.290, or I could just put in 0.29, that's fine. And then 1 minus 0.290, I want to make sure that that's greater than or equal to 10. And so when I check that on my calculator, .27 times 0.29 times 0.71. Go ahead and just subtract that. I think of that as money. So if I gave you $1 for something that cost me 29 cents, you should give me 71 cents back. And sure enough, that's going to give us 87.9193, which is in fact greater than or equal to 10. Then the next thing is we need to make sure that our sample size, 427, is less than or equal to 5% of our population. So this is going to be all women. So I feel that I can be fairly confident that we have a very small sample of all women who purchase books, perhaps, or just all women in general. I'm not sure what the entire population would be, but maybe it's all American women, all women from the U.S., all women in a certain age range. Whatever it is, 427 is a small enough sample for us to say, yes, we have met that condition. All right, so now that we know we can use one prop z int, we're going to go to our calculator, and we're gonna work with this part first. Obtain a 95% confidence interval estimate for the percentage of all women who purchase books online. And I will make note of this. This does say percentage of all women, so we need to make sure to stay consistent with the problem to change our values that our calculator gives us as a decimal format into a percentage in order for our interpretation to be correct. All right, so here's our calculator. Again, we're trying to find a 95% confidence interval for the percentage of women who buy books online. And so what we're going to do is we're going to go, just like we did before, to stat, over to tests. I'm going to hit alpha A because that's where our one prop z int is. And I'm going to put in our numbers that we need. But it's got the old stuff in there. I forgot. So I'm going to put in 0.29 times 427 because I forgot what a number I got. And then, of course, I need to put in 427 for n. But I can't leave that 123.83. I can't leave a decimal there. It's going to give me an error. So I need to go back. I need to change that to 124. Now, if you remembered it was 124, that's great. Otherwise, you can find it within the function itself. Then I just want to hit calculate, and voila, I get my confidence interval. So I'm going to write it out as is given in the calculator first. So notice there's that p hat value that we found in part A. So we didn't have to do that separately. We could have just done the confidence interval and written that down in the process. But we found it wasn't hard. So here's what I've got. But again, I want to find the confidence interval for the percentage of women who buy books online. So I want to change that to 24.734% and 33.345%. All right, we'll interpret this on the next slide just so I have plenty of room to write. But that is our confidence interval. That's my 95% confidence interval for the percentage of women who buy books online. So let's figure out how do we interpret something like that. All right, so here was our confidence interval. I just put it over here again so we wouldn't have to flip back. But what we're wanting to do is to interpret what these numbers mean. And in all of our problems, parts A, B, well, maybe not B, but the parts that we're talking about this situation mentioned, we're trying to find a 95% confidence interval estimate for the percentage of all women who purchase books online. I want to use that phrase, the phrase of what I've been asked to find. I want to use that in my interpretation. So the way I'm going to do this is I'm first going to start off with how confident I am. So I might say we are 95% confident that, and then this is where I'm going to use my phrase, the percentage of all women who purchase books online is between, and then here we go. I'm going to use these numbers I got. And I'm actually going to go ahead and round to 1 decimal place for my percentage. So I'm going to say 24.7% and 33.3%. And there we go. That's my interpretation. So really, our confidence level is going to go in there. We are blank percent confident. This could be 95%, 99%, 90%. Whatever confidence level you use to calculate the interval, that's the confidence level that goes into our interpretation. So we're 95% confident that, and I want to use the context of the problem so that my interpretation is in context. I don't just want to say we're 95% confident that the percentage is between here and here. The percentage of what? What if you have lots of confidence intervals you're interpreting? You need to make sure that whoever you're telling this to knows what you're talking about, or know that they know what you're talking about. And then I put my numbers in. And that's it. Those are the 3 components of an interpretation. Our confidence level, the context of the problem, and then the numbers themselves. All right, so I've got our interval here at the top. It's the confidence interval we found in part C. But now we want to actually think about, what do these numbers mean? And our first question, to help us see what these numbers are telling us, asks, can we safely conclude that 50% of all women purchase books online? Well, we've just said that we're 95% sure that the true percentage is somewhere between these 2 numbers that we found. These 2 numbers are 24.7% and 33.3%, if I round those down like I did in my interpretation. So if we're 95% sure that the highest we can go is 33.3%, that's our max that we're allowing for, then no. 50 is far outside of our interval. 50% is not within our interval. And in fact, it's very far away. If they said, could we conclude that, 34% of all women purchase books online? The answer would still be no, but at least that's close. 50% is very far away. All right, and then here's another one just to see, what do these numbers mean, and how do we answer some questions that we might be asked. So this question says, can we safely conclude that at least 25% of all women purchase books online? And of course, we want to be able to explain whether we think this is something we can say or not. And this one, I typically end up getting a lot of yeses because 25% is within the confidence interval. And that is true in that fact that, yes, 25% is between these two numbers that we found for our confidence interval. However, if we're saying that at least 25% of all women purchase books online, that means that we're saying that proportion has to be greater than or equal to 0.25. However, even though it is a hair's width of a difference, we have that our confidence interval, our lower limit, this number right here, leaves like the tiniest little sliver of a chance that we have a number. Let me erase this. Well, is it not going to let me erase? There we go. And erase this. There we go. So this is less than 0.25. Barely. And yes, this is an extremely small chance that our proportion is actually not at least 25%. However, that's what our confidence intervals are. This is the absolute minimum and absolute maximum that we're going to allow with our 95% confidence. And so I cannot, there is a chance, and I'm going to put small in parentheses. There is a small chance that P is less than 0.25. So no, I cannot safely conclude that at least 25% of all women purchase books online. That's the trickier one of those two questions. And then finally, what do the results of this survey tell us about the percentage of men who purchase books online? And so remember, we did a survey of 427 women. And so this goes back to making sure we define our population correctly and our experimental design that we talked about in Chapter 1. If I want to know about the percentage of men who purchase books online, I need to do a survey of men. So this tells us absolutely nothing about the percentage of men who purchase books online. So we don't want to we want to remember, what have we been, where did we get our data? How did we get it? Who did we choose our sample from? Those things still matter.